Hey guys, let's look at 52, two parts to it, and let's knock off the first part pretty quickly here. It's called adding rational expressions with unequal denominators. It's a big mouthful, but don't forget what an expression is, right? It's not an equation. In other words, it doesn't have an equal sign. So it's just a clump of stuff that you're trying to simplify. Rational ratio means a fraction, and unequal denominators, you know what that is, okay? But let's first prove that it works with actual numbers, okay? Let me just ask you a question. You tell me if you have these two fractions, okay? Find the common denominator and add these. And there's one denominator and there's the other denominator. What is the common denominator? You tell me. It's 14, right? In other words, this is a 2 and this is 7, okay? You don't say, excuse me, you don't say, oh, the denominator is 7 because it's bigger, or the denominator is 5 because it's bigger than 2 and 2. No. What you have to do is treat this like one thing, right? You have to treat this as a 7. So you have to go, okay, well, the denominator has to be the one on the left and the one on the right, but added together, we have to times those together at least, okay? Okay, so it has to be 2 times 7. It's not, oh, it's 7. No, because 2 doesn't go into 7, okay? If you know that, then you'll have no problem doing it with x's and y's because you do exactly the same thing, okay? So here's an example. Take a second to copy this down if you need to, pause it. All right, look at this and realize that you're going to have to treat this just like the 2 and then the 2 plus 5 we did in the last lesson, okay? So in other words, your common denominator is not going to be, oh, look, this has an x and a y. Oh, my common denominator is x plus y. No. It's like saying, oh, my common denominator, that has a 2 and a 5. Oh, it must be 7. No, it isn't. 2 doesn't go into 7, okay? And x doesn't divide evenly into x plus y, all right? So what we're going to do is, anytime you see a plus on these denominators, just mentally kind of treat them as one thing. It's one thing you can't break apart, okay? So our denominator is going to be just like this. Our denominator is going to be 14. On here, it's going to be 2 times 7. And over here, it's going to be 2 times 7. You see that? We can't just do the 7. We have to do 2 times 7. On this one, we can't just do the 2. We have to do 2 times 7. So on these, exactly the same thing. There's one denominator. There's another denominator, which means the fractions are going to have both denominators multiplied together. Okay? Yeah, you know what I'm going to do? I'm going to use different colors so you can see this. Okay? So we're going to write these with new denominators. Okay? I'm just going to plus them here. I'm going to do my A, I'm going to do my B, I'm going to do my X, I'll do my X plus Y. This time I'm going to just kind of put parentheses around them. Okay, you know how to handle fractions. Whatever you do to the bottom, you do to the top, right? I mean, you do the same thing to the top and the bottom. Same thing here. You tell me, this has to be my common denominator. It's got to have this and it's got to have that multiplied together, just like we had 2 times 7. And not just 2 and 5 or whatever. Okay, it's got to have those times together. Okay, well, I'm starting with an x in this one right there, right? What do I need to do to the x to make it like that? And the answer is I'm going to have to multiply by x plus y, right? Okay, well, I don't just do that to the bottom. I have to do it to the top as well, remember? So I do the same thing. Boom. Okay, now on this one over here, I started with this. And I ended up with that. What did I do to this to get that? And the answer is I multiplied it by x, right? So that's what I'm going to do over here. I'm just going to put the x there. Front and the back, it doesn't matter. And I'll put the x here, whatever. Okay. So all I need to do now is go, okay, well, I have both of these have the same denominator, which means I can put them both over one, denominator. And then all I do is go, okay, I got my bx here at the very end, and something that's a plus. And I can go, okay, I'm just going to take my a and distribute it to the x and to the y, right? So a times x is ax. That's going to be a plus there. And a times y is ay. And this is called simplified, even though if you look at this, it looks like a little more complicated than it is that. But the reason they call it simplified is because it's one fraction instead of 2. So once you learn that principle, that's it. You just keep doing it over and over. Okay, let's try another one. All right, take a second, pause and copy this down if you need to. All right, same thing here. you're going to have to look at this and go, okay, my denominator is going to have to be this clump here multiplied by this, okay? So I'm going to go ahead and start off with my 4x plus a over here, and then plus my c, and then this one has an a plus b, and this one has an x. Now don't forget, my common denominator is going to have to be a plus b times my x, right? It has to have both of those multiplied together. Well, I've got this already on this one. What do I need on this in this fraction here? Obviously, it's an x, right? I'll just multiply by x, okay? And then what I'll do is I'll go up here and go, well, since I multiplied the bottom by x, I'll multiply the top by x. We'll do that in a second, okay? Done with this one, all right? This one, I already have an x, but I need to have this, which means I'm going to have to multiply it by this, okay? So I multiply this by a plus b, and then since I did the bottom, I need to do the top as well. Same old thing, okay? So then our problem just becomes, okay, well then I've got one denominator here. I got an x, and I have an a plus b, all right? Well then I just go, okay, I'm going to, distribute these terms and then add them all together. So x times 4x is 4x to the second power. X times a is xa. Okay, done. All right, plus c times a, ca, c times b, cb. Now look at that numerator. Are there any like terms that we can add together? No, not really. They're all different. So this is a one fraction. Everything's over one denominator instead of having two fractions that we started off with. And that's it. That's how you do it. Okay, whatever you do to the top or bottom, you do to the top. Okay, we'll do one more. Take a second here if you want to pause it and copy this down. Okay, this is different obviously because first off there's three of them and not just two. And the second thing is there's no denominator in that third one. But of course you know what to do. Every number in the world or variable in the world is a fraction as long as you put it over one, right? Okay. So it doesn't matter if there's three of them. You just do the same thing you did with two of them. So anyway, well, you tell me, what is the common denominator of x and m and 1? What's the common denominator? Just xm, right? Okay, so that's what we're going to do. Okay, so I'm just going to copy down the same old three fractions that we had. Okay, and I'll go, there's my c over m, and I got a d over 1. Okay, well, I know that the common denominator is xm, is xm, is xm, right? Okay, so let's look at this first one. I already have this. Okay, all I had to do was multiply it by the m. So that's what I'm going to do up top as well. I'll put my xm here. Okay, on this one, I already had my m. I just have to multiply this by x, right? If I do it down here, I do it up there. And on this one, I only had a 1. So I had to multiply this by xm. Well, if I multiply the bottom by xm, I multiply the top by xm, okay? And that's it, okay? And I just lump these all over one fraction. Now I've got m times a, ma. M times b, mb. And then I've got a cx there. What is that, cx? And then I got a dxm. Okay, so dxm, yoink. And then I got 4 terms, and then they're all over xm or mx or whatever you want to call it. What is it called, mx? And there you go, and that's it. Okay. All right. Last one. I believe this is the last one we're going to do. Yeah. Copy it down. Take a second. Looks complicated, but if you know how to do regular old fractions with numbers, you can do it with this too. Let's go ahead and make this over a 1. Okay. Well, you tell me what is the common denominator of b plus c, 1, and k. And obviously the answer is, k times b plus c, right? Okay, so let's actually write what we already have. I got an a here. I already got it. I'm going to put a parentheses around this. Okay, I'm going to go minus, because that's a minus, x over 1. And I'm going to go plus, excuse me, d plus m over my k. Okay. This is what we're looking for. X times b plus c. That is my common denominator, right? Okay. Well, you tell me what I have to do each time to make that happen, okay? I've already got my b plus c. What do I need? I need my x, right? Well, x, and there's my x to match it up, right? X on the bottom, x on the top, okay? I've got a 1 here. I need an x times b plus c. So I'm going to have to go times, you know, x times b plus c. So I'm also going to have to go times x times b plus c. Okay, you don't have to put parentheses around that second x, but I just did it just so you can see it better. On this one, I already have a, oh, wait a second, that's not an x, it's a k, my bad. Okay, you guys are probably wondering, what the heck's this guy doing? Okay, that's a k, all right, that's a k. Okay, so that's going to be a k as well. Yeesh. Okay, there's my k, and that should be a k as well, brother. Okay, anyhow, all right. I've got my, and I'm going to turn that into a k as well. Okay, all right. I've got my k already, okay, so I just need this part right there. So that's what I do to this, okay? And if I do it to that, I've got to do it to this as well. There you go, okay? So, my new, ugh, what a mess. Well, I know at least I have this, okay? At least I have a k and times b plus c. I know that's my denominator, okay? Well, I had to multiply the a by k. I'll just do ak, so that's done. And then k, excuse me, let's make it a little neater here. X times k, and then times b plus c. Everybody see what I'm doing there? Okay, I'm just trying to rewrite this part right a little neater. Okay, so we're going to have to distribute if you see those, you know, terms inside. So xk times b, that'll be xkb, excuse me, and then xk times c is xkc. Okay, so we're done with this part. All right. Third one, I've got my k times b plus c. Okay, which this time I'm going to have to do that distributive property where you go and do one at a time. So let's just do d first. All right, d times b, db. D times c, dc. Okay, done with the d. All right. Now I'm going to do m, and then m times b is mb. Then m times c is mc. Okay. Gosh, that's a lot of terms for a numerator. But anyway, and that's considered a simplified fraction. Maybe it didn't look so simple, but at least it's just one fraction instead of 3. So there we go. All right. Okay. Let's look at the second half. Not too much algebra here. This is called average versus overall average. You know how to find the average, right? Let's say you have 10 quizzes, and you know, you add them all up, add all the points you made, and then you get a total, then you divide by 10 to find your average, right? That's how you find it, okay? There are overall averages, though, as well. They're a little bit different, okay? And this is how they work, okay? Let's say you have the average of the first 90 numbers was 4. In other words, there's a huge piece of paper, boom, 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 and you just all these numbers, okay? And you go, okay, the average is 4. You write that on it. There's 90 numbers. Okay? Then you have another piece of paper, and there's only 10 numbers, and their average is 6. What is the overall average? Okay? Well, the tempting thing to do is go, oh, it's right between 4 and 6. 5! Okay? But if you think about that for a second, there's so many numbers here that average up to be 4, and there's only a few numbers here that average up to be 6. So it's not going to be 5. I mean, if there were 90 numbers that average to 4, and then 90 other numbers that average to 6, well, that's the same number of numbers you're averaging, so that would be 5. But there's a lot fewer of these that average up to be 6. So what's going to happen is, since there's so many here that are 4, that average to be 4, and so few that average to be 6, the overall average is going to be closer to 4 than it is to 6. It won't be 5. Okay, so let's look what happens here. This is the method. Okay, you ready? Okay, what you do is, you look at that first sheet of paper. If you have 90 numbers, and they all average out to be 4, what's the total of all those numbers if you were to sit there and put each one of them in a calculator or just add them all manually in your head? At 90 numbers, they average out to be 4. All you would need to do is just go, okay, well, it's just going to be 90 times 4, right? That's the total. So the total on this sheet of paper right here of all these numbers is 90 times 4, or 360, okay? That doesn't mean they're all 4. They just add up to 360 because their average is 4. On this one, there are 10 numbers. 10 numbers, you know, they average out to be 6. Well, I'm sure you can figure out if you added all those 10 numbers and they average out to be 6, the total is going to be 60, correct? Okay. So you tell me how many numbers we have total on both of these sheets of paper. 100, right? Okay, 90 here, 10 there, right? So the total you have is this part right here. You have 360 plus 60. That's the total of adding all the numbers, okay? So the total is 360 plus 60, or 420. And all you need to do to find the average is to divide that by the total number of numbers. 90 plus 10 is 100. Well, you don't have to sit there with a long division and do that. You just move it over twice. Divide by 100. See, the average is 4.2. That is closer to 4 than it is to 6, okay? Which is sensible, right? You have so many numbers that average out to a 4 and so few that average out to a 6. You're not going to get right in the middle of 5. You're going to be way skewed toward the ones that are 4, and we are. Look at it. It's 4.2. That's a lot closer to 4 than it is to 6. Okay, that's the method. Okay. Oh, I guess that was the only one we did. Okay. All right. Try the practice problems, and we'll come together in a couple of minutes here. Okay. So copy down A, and we'll do that one. Okay. Here is A, and let me go ahead and just write this over a 1. Okay. Now our common denominator is going to be ym, right? Okay, so I'm just going to write these over again. X over y minus b over 1 plus c plus d over m. Okay, all right, and we know our common denominator is going to be ym. Y times 1 times m. Okay, that's what we need. Here, we don't have that. We just have the y. We need the m. Boom. We add it, or multiply it, and we do the same thing here, right? The second one, we don't have anything except a 1. We have to multiply by y and m, which is what we do on the top as well. Okay. This one, we have the m. We lack the y, so we go y. Then we go y here, and you kind of put these, because you're multiplying the y by both terms. Okay. All right, xm, you can just put it there. Minus bym, boom, there you go. And then we can just take the y and distribute, right? Okay, so y times c, and then y times d. There we go. And everything goes over one denominator, and that's A. Okay. All right, so pause it and try B. All right. Well, let's do the same thing. Let's rewrite this thing over. We've got 1 there, so I'm just going to rewrite the whole thing here. So 5b plus c over a plus b minus x over b plus c over 1. Okay. Obviously, we are looking for the common denominator, which will be this. Don't forget, that's one hunk. You can't separate it as a denominator. So don't say that your common denominator is a plus, oh, it's a plus b, because there's a b there. That has both of them. Oh, it must be a plus b. No. That's like saying, oh, you know, a b is 8, and then b is 8 there, and then a is a 4. And you go, oh, it's going to be, there's an 8, and there's a 12, 4 plus 8. Oh, the common denominator is 12. 8 doesn't go into 12. Okay, so it has to be both of those multiplied together. Okay, so this is our common denominator. B times a plus b. That is it right there. Okay. Got to have both of those, all right? On this one, we're good, except for we're missing the b. So we're going to go b and then times it by all that, okay? Which means we do it at the top as well. So there's our b. We'll get to that in a second, okay? On this one, we need this. We only have the b, so we go, okay, times a plus b. And then, of course, at the top, we do the same thing, times a plus b, all right? This one, we don't have either one of them. So we're going to have to multiply it by b and, a plus b. So the b and the a plus b, we don't have either one. So we do the same thing, times the b and then times the a plus b. Okay, so let's do our multiplication all the way across here. So we have b times 5b, that's going to be 5b to the second power, plus bc, minus, let's see, 8x times a, and then minus x times positive b is minus xb as well. Okay, and then plus cb times a is just cba, And then CB times B is CB to the B to the first, B to the first times B to the second. There we go. And then all this over B over A plus B. And you might have thought, wait a minute, what about the 1? It's assumed. You don't have to write 1 times anything. So in red, that's your final answer. Check it one more time. Any like terms we can, no, they're all different. Okay, there you go. All right, now try C, your average, overall average. And you know, if you want to write 2 sheets of paper or whatever, remember that method. You can go back to it and look at it if you want to. Okay, I'll go ahead and pause it. Okay, well here's your, you know, if you want to do it this way, here's your average of your first 5 weights. Okay, there's 5 of them. 1, 2, 3, 4, 5. Okay, and the average is 10. Will you tell me what's the total weight of all this group of weights? There's one, there's one, there's one, there's one, and there's one. What's the average? I mean, excuse me. What's the total of all the weights? 5 times 10, right? So it's 50. So the total is 50. Okay. Here's our other one. Got a bunch of weights. Okay. And there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 weights. All right. Their average is 25. So you tell me how much weight is on that entire, I don't know, let's say it's one corner of the weight room or whatever. What's the total amount of weight in that weight room right there? 250, right? So the total weight is 250. That's 25 times 10, right? What's the overall average of all the weights? Well, before you even figure this out, okay, we got a bunch, we got more 25s than we do 10s, right? So right in the middle of 25 and 10, well, let's put it this way. Is the average going, overall average going to be closer to 10 or closer to 25? Be closer to 25, right? Because there's a lot more of them that weigh 25 pounds. So it's not going to be right in the middle of 10 and 25. It'll be closer, you know, kind of skewed toward that 25. Okay, so let's figure it out. We have a total of 50 pounds plus 250 pounds. That's 300 pounds, right? Okay. How many weights do we have total? How many total? Not the poundage, but how many individual weights do we have? Okay. You know, we have 5 here. We have 10 here. That means we have 15 total, right? So to find our average, we're going to divide 300 by 15. All right. And once you do that, you probably see 30 divided by 15 is 2. Then add another 0. So the average weight, overall average, is 20 pounds. Do you see why that's sensible? Okay, you're going to have it closer to 25 than you are to 10 because there's, those 10 with the 25 weights are really skewing the average toward being closer to 25. So, all right. Okay, that's it for 52. You guys have a great week.